Welcome to The Explainer. Today, we're completely tearing up the idea that geometry is just some dry subject stuck on a chalkboard. Instead, we're going to look at what it truly is, the hidden, structural blueprint of the entire universe. Seriously, if you're ready to completely change the way you see the physical space around you, you are in exactly the right place.
I want you to take a second and really look closely at your everyday surroundings. The screen you're looking at, the room you're sitting in, the trees right outside your window. What if I told you that absolutely none of it is random? What if the physical world was literally written in a secret, highly logical language? Well, it is. And the crazy thing is, once you learn how to read this language, you really can't unsee it. So here is our flight itinerary for today's explainer. We're going to cover geometry in nature, blueprints of human architecture, the geometry of sports, artistic patterns and symmetry, and finally, we'll wrap up with a hands-on room measurement challenge.
Okay, let's dive into this. Section 1, Geometry in Nature, and those flawless geometric patterns.
You know, the very word geometry stems from the ancient Greek words geo, meaning earth, and metri, meaning measurement. Thousands of years ago, early philosophers weren't just, inventing random shapes on parchment. They were actually building the very first mathematical toolset to measure the physical earth and decode the spaces upon it. They were discovering the underlying code of reality itself.
Because, let's be real, nature was engineering perfect shapes way before humans ever picked up a ruler. Think about the tessellating hexagons of a honeycomb. That's a shape mathematically proven to maximize storage area while using the absolute least amount of beeswax. Or the intricate six-fold radial symmetry of snowflakes, which is strictly dictated by the molecular bonds of water. From the concentric circles radiating from a flower to the stunning spiral curves of a shell, nature is the ultimate architect. It constantly optimizes for survival, and its chosen language, it's geometry.
Moving right along to Section 2, Blueprints of Human Architecture, from the macro to the micro.
Our modern world relies heavily on these strict shapes to function safely. We use load-bearing triangles to distribute weight across massive bridges, and towering vertical rectangles and parallelograms for our skyscrapers. We construct grand hemispherical domes on temples, precisely parallel lines for our road systems, and perfect right angles for the windows that let light into our homes. Every single piece of architecture around you is a highly calculated combination of geometric polygons and angles.
And this brilliantly illustrates how we pull this off. How do we know the height of massive skyscrapers or even mountains like Mount Everest without a giant tape measure? Well, we use the principle of similar triangles. By comparing the shadow cast by an object of a known height, like a simple stick, with the shadow of a massive building, we can establish proportional triangles. Because the sun hits both at the exact same angle, the corresponding sides are in the exact same ratio. It's called indirect measurement, and it literally changed human engineering forever.
All right, let's pick up the pace and shift to Section 3. The geometry of sports and the rules of play.
So, how does geometry actually govern the way we play? I want you to picture your absolute favorite sport. Whatever it is, just visualize a game in progress. Now, think about the athletes. Beneath the sweat and the cheering crowds, every single game is bound by strict, invisible, and sometimes very visible geometric lines. These shapes are hiding right in plain sight, and they literally define the rules. The vast rectangles of a football or cricket pitch dictate exactly where the ball is in or out of play. A basketball court? That's a masterclass in strict geometry. You've got intersecting perpendicular lines, precise parallel lanes, and exact semicircles. Even the globally recognized Olympic rings are set of 5 mathematically perfect concentric circles. And hey, if you prefer a mental sport, the alternating square grid of a chessboard provides a flawless coordinate plane for every single strategic move.
Let's transition to Section 4, Artistic Patterns and Symmetry, exploring cultural geometry.
So the crucial point is the incredible contrast between functional architecture and cultural art. We just looked at rigid, load-bearing shapes that have to withstand gravity, right? But in art, geometry becomes this fluid, symmetrical expression of human creativity. It's the exact same mathematics, just used to inspire human emotion rather than hold up a heavy roof.
Human cultures across the globe have leveraged these geometric principles for centuries. Just look at the intricate symmetry of Indian Rangoli patterns, or the mesmerizing rotational symmetry of mandalas, or those endless tessellations in Islamic geometric patterns. Even traditional folk arts, like Madhubani and Warli, rely heavily on basic triangles, circles, and parallel lines, all woven together to depict complex stories of human life. The math is completely universal.
And that brings us to Section 5, the Room Measurement Challenge, our hands-on application.
Okay, theory is great, but application is where the real learning happens. It is time for you to decode the secret blueprint of the room you're sitting in right now. So, mentally prepare to get up out of your chair.
Here's your challenge. Step 1. Grab a tape measure and find the length and width of your room. Step 2. Sketch out a scale drawing on a piece of paper. And Step 3. Calculate the perimeter and the area. Just to lock in the math before you start, perimeter is your boundary. If you physically walked the walls of a rectangular room, the calculation is just 2 times the length plus 2 times the width. Area, on the other hand, is the two-dimensional space inside those boundaries. Think of it kind of like counting every single floor tile in the room. It's simply the length multiplied by the width.
Now, what's really interesting about this is that the calculation is just the beginning. Once you've mapped your room, really look around. Identify the parallel lines. Spot exactly where the walls meet to form perfect 90-degree right angles. Hunt for the polygons hidden in your furniture, your rugs, your bookshelves. You are quite literally sitting inside a massive, interactive geometric grid.
So, I'll leave you with this. How will you view your surroundings differently now that you know the world's secret blueprint? From the snowflake falling outside to the floorboards right beneath your feet, geometry is the fundamental language of reality. Keep your eyes open, measure twice, and never stop exploring the math that's all around you. Thanks for joining me on this explainer.